Okay, this is the Algebra 1 Unit 6, Lesson 5 video. This video is all about taking the standard form of quadratic equations, which you've seen in the previous lessons, and converting it into vertex form. So let's talk real quick about what those two forms are all about. So standard form of quadratic functions looks like this. Or with numbers, it would look something like this. Just as an example. And so that's what we call standard form. You just have the coefficients of A, B, and C, and they go in the equation like you see there. Alternatively, you have what you call vertex form, which actually was the form we were mostly working with when I did the lesson about transformations. Vertex form looks like this. Where we just have values for h and k. So for instance, it could have y equals x plus 2 squared minus 7, where this value here and here tell us about the vertex of the function. In fact, they tell us that the vertex is located at the point -2, -7. Which is the usefulness of the vertex form, is it allows us to easily see where the vertex of a function is. Problem is, we sometimes will get them in standard form, and we really want to be in vertex form. So how do we convert from standard to vertex form? Well, we do it by completing a method, or doing a method called completing the square. Okay, so I'm going to go ahead and do a few examples of that, of how to do what we call completing the square. And then we'll look at the lesson and kind of see how that works for us in the actual lesson. So completing the square. So let's give ourselves an equation in a standard form. Let's say we get the following. Y equals x squared plus 4x minus 1. And when we say we want to complete the square, let's try to scroll down here, we are saying we eventually want this to look like the vertex form. We want it to look like this. So in order to do so, we have a couple of steps we have to take. First of all, we are going to do what they call transpose C. I'm going to put a step-by-step list into the notes, but step 1 is to transpose C. And so C, looking at the standard form equation, is the constant term right here. So we're going to transpose that, and that just means to move it to the other side. So pretty straightforward. We're going to add, not 10. We're going to add 1 to both sides of the equation. That's always step 1. You got to get rid of this term there. So we end up with y plus 1 equals x squared plus 4x. So now, when we say completing the square, this is kind of what we're talking about. We need to complete this expression so that it is what we call a perfect square trinomial. And I will post, again, in something in the notes about perfect square trinomials, but you should remember that perfect square trinomials are things that when you factor them, they factor into the same two terms. They factor into x plus 3, for instance. And so then you would write x plus 3 squared. But we're not going to have 3. We're going to have something else. So we're going to leave all that there for us. And we're going to try to get it to where it factors to be one of those. There's actually a pretty easy way to do it. The way we're going to do it is we're going to do a little trick, and we're going to add the same thing to both sides of the equation. And what we're going to add is we're going to add whatever makes this become this. Let me kind of move this little 2 down here. There we go. Give ourselves a little space. And the way we're going to do that is we're going to take the b term, we're going to divide it by 2, and then we're going to square it. And that is going to give us our new c term. So this little equation right here is key to this whole process. Again, I'll post all of these steps in the notes so you can follow along. But in our case, b is 4. So 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4. That number is what I'm going to put here and here. So let's take it to the next step. Over here, I'm just going to combine everything. Y plus 5. And then this factors to be x plus 2, x plus 2. And you'll notice the number we got over here is the number that we put here and here when we factor. Next step, rewrite the problem as a perfect square, x plus 2, with y plus 5 on the other side of the equation. We're going to then solve the equation for y. We're going to subtract 5 from both sides. So the final result looks like this. This is now in vertex form. All right, let's do one more example so we can kind of have that point driven home. And then we'll look at the one in the lesson and make sure that you guys are good to go. So let's say I had y equals x squared plus 6x plus 4. So this cannot be factored, which is something I should have said earlier. Typically, if it's already factorable, you can go and do that. But when we're doing completing the square, again, our goal is to get it to look clean like this. And so we're not going to do factoring. We're going to jump straight into completing the square. So first things first, we're going to move this 4. That's what we said when we said we transpose the c. So y minus 4 equals x squared plus 6x. And then I'm actually going to give myself a little room over here by moving this over. And after we do that, we need to figure out what can I add here and here to complete the square. I should have said this earlier, but it's fine that I say it now. The reason we add to both sides of the equation is because that's simply what we have to do in algebra. I couldn't just add some number over here on this side without adding it over here. That's just breaking the rules of algebra. We have to keep the equation balanced by adding the same number to both sides. Again, we're going to follow the b divided by 2 squared process. Our b is 6, so 6 divided by 2 squared is 3 squared. So that's 9, goes here and here. Y minus 4 plus 9, so we're going to simplify that side of the equation. Y plus 5 equals, and then we're going to go ahead and factor. And I'm going to go ahead and jump straight down. We know that this is x plus 3 from right here. X plus 3, x plus 3. Let me get that in the right color here. In fact, I'm just going to do this whole, I'm going to redo this whole line. Sorry about that. So we're going to do y, again, y plus 5 from this right there equals, again, x plus 3, x plus 3, y plus 5 equals, and then this is the same, so we can rewrite this as x plus 3 squared. And then the last step is to move this 5 back over, leaving me with y equals x plus 3 squared minus 5. And now we're in vertex form. So then we would go and we would be able to graph the vertex. The vertex of this would be -3, -5. All right, let's jump over to the lesson and see what we have to do here. So you're going to be doing that with the one they give you. They give you this equation right here, y equals x squared plus 4x minus 5. Follow the process. I will post the steps in the video notes, but you're going to follow the process that we just got done doing over here in our examples. So take a look at that. Starting in number 2, use the values of the vertex and point to write the equation of the graph in standard form. So we're actually going to take a slightly different approach on this one. I'm going to go ahead and jump over to Desmos, and we're going to start by looking at these answer choices down here. We're going to put these in Desmos, and then we're going to see which one matches the graph up here. So let's do that. So we'll just start with the first one. Sorry about that. Y equals x squared. Y equals x squared plus 2x plus 4. You can use a regular calculator, but Desmos is nice because you'll be able to quickly tell what graph matches. So this doesn't match. You should be able to see that right here. This one goes down below the x-axis, whereas the Desmos here, you can see it's way above the x-axis. It doesn't come down below like that. So that can't be it. So we've already eliminated answer choice 1. Go to the next one. The only thing that's different about here is we have negatives instead of positives. So let's go there. Let's change that. Minus 2x minus 4. Much closer. Now let's go look at these points and see if we think these are good. Well, we can see 1, -5 is the vertex. That looks good right there. We can also see the line crosses just past the 3 and just past the -1. Up, just past the 3, just past the -1. There's even a y-intercept at -4. Let's see if that matches up. Yes, look right here. So clearly that's going to be our answer for that one. So you notice how whenever I'm given graphs and all I'm doing is just matching equations with graphs, let's jump over to Desmos and just graph these and see which one matches up. All right. Here we have some review questions. These come up pretty often. List the order of operations in correct order. Oh, sorry, lost my lesson there. Let's go back down. Wow, there's a lot of review questions on this one. I'm going to pause this video and I'm going to do a separate video just over the review questions.